Students, friends of BSc 6th semester will continue today again discussion on C language, and that is a topic input and output operations. In that we are discussing formatted input. We have two types of input: formatted input, formatted output, unformatted input, unformatted output. We are discussing first one, that is formatted input, and for that we have input function called as Scanf. And the syntax of Scanf already we have discussed. I have written here Scanf in parenthesis, a double quote, control string, a comma, address list, and then semicolon. This is a format of formatted input statement. Here this input statement, this formatted input function is to read the data from the standard input device called as keyboard. Yesterday even we have seen this character group. This is control character group or conversion character. It's called as character group, and its meaning, and this meaning is true for input statement. And this table will holds good for output statement. See, normally in any computer language we say read the data, in the sense you are instructing a computer, a machine, to read the data, and that data is to be supplied by the user. Reading means you are asking that computer to read the data, that is input, and then you are asking the computer, giving the instructions to the machine to write the data. Writing the data is the output. Here we are calling it as read means to the input, and the meaning remains same. Write means to the output, or print means to the output. Same table holds good. Maybe there may be addition as per the documentation or the literature. Recent things, recent developments may be the addition, but these things will holds good. Well, now what are the types of data we have seen? Numeric data and non-numeric data. Fine. Integer data, float point data. We have to discuss in detail. If an integer input is there, I want to supply data, that is input data, in the form of an integer number. Then how to write an input function? Input function, that is using a formatted input function Scanf. We are still discussing Scanf only. Let's go for this, that is input input. Alright, this was capital. Fine. Integer input. Right. Look at this character group and the meaning. Here we have second, that is person, and the converting or controlling character. It will read a decimal integer. It will read a whole number, an integer. So from the character group table here, they will not give you the table, you have to remember it. You have to remember it. A program writer or C program user, you can say, has to write, has to remember this character groups and their meaning. Okay, let us go for one example. That is, say I am using this percent symbol. We have to write this in as a control string, and this is a character group according to this table which I have shown here, is used to read the input data for a decimal integer, for a input decimal integer, and that through a standard input device called as keyboard. Once we got this, I'll write the same thing here as an example. Say Scanf. This is formatted input. Okay, I have written here its syntax. Inside the parenthesis, inside the double quote, I'll write this percent symbol, D, fine, close this, and then comma, and number. This is address list. It starts with amperes. Here in input, formatted input. Now, this is the statement we have written in a program, right? And this is input statement. It works as an input function. No doubt, this address list which stores the data in particular memory location. Maybe we have declared this in declaration part. Now we have to give input through a standard input device called as keyboard. Suppose I want to enter the data into this. Say the data is 88. This data, let the input for the above statement, for this statement here, be 88, 2 digit. This 88 number, that is a whole number, integer, decimal number, and it will be stored in the memory location, represented by a number. Here, this is address list where the memory to be stored, and when we feed this, when we give this data as a 88, this 88 number is stored, 2 digit number is stored in this memory location. And this is very simplest format of an input statement. This statement is simple. Statement does not specify how many digits the number is containing, or how many digits are there in a address list or a variable called as number. Right? As an input, you can write here, when you are keeping it simple, you can write it as many as the digits you want, and that will continue depending upon the how many bit computer or your machine is. Now, I want to specify in a variable list the number of digits. That means the same statement called as input statement, Scanf, I want to specifically write the data so that the data is accepted through the field specification. What is meant by field specification? Field specification. Hope you got this. Field specification means the number of columns reserved for a particular number. That number to be input. Number to be input, or you can say output. Suppose you are reading 3-digit number, digit number. Already we have written this, reserved the memory for this variable, that is number, and that I am writing the 3-digit number. For variable say number, or you can change that name of the variable. Right, so I can write the same thing, Scanf, okay, into bracket, that is parenthesis, double quote, percent sign, as it is for decimal integer. D, I will close this double quote because it is only one, control string, and write say number or NUM. Instead of number, I will write NUM. I want to feed the data now, that is 86, 3 digit, 1, 2, 3, 3 digit, which is an integer. According to this control string, this must be an integer, otherwise it will show an error. So here this converting character group D for a decimal integer is used in the control string. Converting character group for a decimal number, and this is used in control string of a Scanf, that is a input, formatted input function. This should be specified as a control string. The number of digits to be inputted are 3, so I'll rewrite this. Okay, say Scanf, fine, this is as it is. I'll write the symbol, percent symbol, and then 3D, close this, and ampere sign number. Okay, this is. Now, this 3 indicates what is called as field specification. It gives the one-dimensional array, the number of locations or the field specification or the columns for that number. I'll write this number that is here in column, that is 3, say 8 and 6. 3D. Suppose this number is 5 decimal, means 5 digits. So here I will replace this as 5D. And the number, say for example, you can write any number 5D. You can put this any number of 5 digits, say instead of this, that is 2, 3, 4, 5, 6. It is 5 digits. The field width here is 5 digits. I have written. If you replace this by 3, the field width becomes 3 digits. Width of input number. If we are going for an 8 digit, that will be here. You should write 8D. Between a percent symbol and a control character letter, that is D, for decimal integer number according to this. Now, sometimes what happens, we specify this, say 3D, fine, and we give the input, that is 5-digit number. When you have specified a field specification for a decimal number to be inputted through a standard device called as keyboard, here you have written 3 and you are feeding or you are inputting a number which contains 5 digits. It will, this is nothing wrong in it, it will accept say 2, 3, 4. Remaining 2 digits will not be seen as output. Hope you got this. Only these 3 numbers are stored in the memory location and the other 2 are not stored here. So what happens here, this number which we are feeding as an input is, digits are right justified in formatted input. Right justified in the sense, if I write this number 2, 3, 4, 5, 6, 7, 8, the rightmost digit will be first, second, third, fourth, fifth, sixth. It is justified from this side. Unless we should give, say, proper specification here. Proper specification. So digits are justified from the right, okay, or in a formatted input. If I give the input, say with this example, if I give the input, say -2, 4, 6, 8. 1, 2, 3, 4, 5. Field specification is 5 and we will write this number. I'll rub this now. We will write this number like this. We can show it drawing because we are learning it. We can show it in terms of column 1, 2, 3, 4. 1, 2, 3, 4 and say 5. Let it be like that. So this minus sign it will come here. Or let us write 8, 6, 4, 2 and then minus sign. Okay. Now, if I want to input this number which is having 5 field specification, you have to write this. I have to write this. Now, if I give, say, field width, this is called as field width, a number written between % symbol and the character group letter, the number called as field width, the number of columns reserved for a number. Look. I want to field this number and I have given field width here 8. Field width here 8. What happens here? Okay, according to specification, this Scanf format we have written 8D. So when I write this, this will be minus, this will be B, and this will be B and this will be B. B stands for a blank. It justified from right. That's 1, 2, 3, 4, 5. I have given here field width, that is 8. Including sign, this is, it's a negative number, negative integer. So that is 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 and the remaining will be blank. The user should write this. User should write this. So this is about how to use the formatted input using the scanf function, input function, which has a format, means format like this or syntax like this. We have discussed only one case, that is for an integer. Now, in this scanf, we have taken only one character group. If there are two or more character group, how to write this? Let us see with one example. Multiple character group. So scanf, here parenthesis, double quote, percent sign, D. This is 1. Either you can give a comma here, or without giving comma you can write without giving any space, D. Without giving any space you can write D, and close this, give the comma, the separator, and then variable or address list, say amperes and P, say amperes and Q, say amperes and R. Right. Or P, Q, K, anything you can give. This is for decimal integer, right? If you write the specification here, that will be matched with this. For this, it will match with this. For this, it is matched with this. If you are not given field specification, there is no question of matching here. Sometimes I want to give, say, more data here, more control string groups, and the more number of say variables. Out of that, I want to skip one. I'll write for that, say, I'll write here in between what is called as the same asterisk and D. Okay, what happens here? Say P is equal to, say value of P is say 87246. This is input. Say Q is equal to, again it is decimal and it is 846, and say R is equal to say 24. These are the data to be given through keyboard for this. That is P is equal to a decimal. We have given this. We have not specified. Here the asterisk is used. This asterisk indicates that the value of this Q variable is skipped, avoided. So you don't want to give a value to this, okay, assigning value to the variable. So you want to skip. You can insert here asterisk. Automatically it will not take the value of this. It will take for this. It will take for this, though you feed, it will remain empty there. Hope you got this. Sometimes we want to have a more accurate decimal integer. For that, how to specify a control string in scanf. In a control string, we write, instead of this is symbol, percent symbol with D for a decimal integer, and we have written according to this, read a decimal integer or print, and this will be replaced by for a long integer, length to have precise, okay. I'll write a symbol and then LD. This here it's not appeared, okay, LD. So here this character L stands for a long integer. long integer, and we have discussed about this long, short, signed, unsigned in type or data type called as modifiers or qualifiers. For a short number, I will write this D. Instead of writing the D, I will replace with this sign HD. This is half of the short integer. It is used for a short integer. I have written here. Read decimal. Okay, short integer here. Okay, read short number it is. It is mismatching. Read short number here. That is H. That is half of the length. H stands for half. It should be half. That decimal integer should be half, or it should be written half of that. It is called as short. Hope you got this. Short integer number. Let me write using this as LD and HD a scanf here. So example scanf. Okay, inverted double quote, print, say LD, that is percent symbol LD. Okay, whether you give comma or leave it HD, and then complete this, comma, say amperes, say X, amperes Y. This integer, that is this variable, you can say variable which is declared as integer will have a long integer, and this variable which is declared as integer in a declaration part will have short integer. Short integer. Sometimes we have to use unsigned number. See, if I refer to the roll number of a student, roll number cannot be a positive or a negative. It should be unsigned. If the number has to be accepted as an unsigned number, then how to write a scanf function using the different character group and their meaning. If the data or input is unsigned number, say in that case I will write the scanf, just a minute. Scanf, say, okay, inverted, that is double quote, percent sign, symbol, you can use this U here. It is U, read an unsigned integer, and then comma, okay, amperes and say roll number, or I'll write roll. Fine. So this will accept an unsigned number. Even if you feed a signed number, it will not accept. It accepts only unsigned. Okay, this is about how to write a formatted input using a scanf function, that is integer, and different categories or different examples, possibilities which we have discussed here. Let me go for floating point input. Floating point input. So far what we have discussed is decimal integer, that is integer input. Floating point input. Floating point input. Floating point input. Let me write thus. Look at this table, character group table. %F, read floating point number. E also reads a floating point number. Okay, this is, it read a decimal number. E reads floating point number, F reads floating point number, G reads floating point number. Let us use this here, that is floating point input. So floating point number can be input using, say, percent symbol and F normally. A specification. So field specification greatly not specified for a real point number or real point input. Whether it is a decimal or scientific notation, it will. Scientific notation in the sense 2 into 10 raised to minus 3. Okay, 3 into 10 raised to 10. 3 into 10 raised to 8. We use that data as velocity of light. Okay, so or Avogadro number, anything. That is, we write 10 to the power. Here it is written as exponent e to the power. So we cannot write in C e to the power as we write on the paper e, say minus, say 10 to the power minus 3. E minus 3, 10 to the power. So that is called a scientific notation. So for a floating point input, if we want to feed the input as a real number, we write percent symbol and F as a field specification that should be written in a control string. So let us write a statement which accepts a real point value for a variable, certain variable, say x. Alright, Scanf 1. So this is double quote, percent symbol, yeah. Okay, this is complete the code, and amperes and x. So here we have declared in declaration part x is a float. X is a float, that is a real point number, real number. And here using Scanf, that is formatted input, we are inputting through a standard device keyboard, writing this. Suppose I want to enter the value, computer will, it will ask, machine will ask to enter the value of x. Okay, you can write it in a command, enter the value of x. Okay, when it asks for the value of x and say x is equal to 26, you are feeding it as a 26. You want to feed it as